For today, we're going to look at a circle, which is kind of interesting because we really want to focus on functions, and a circle is not a function. Can you tell me why the circle is not a function?
Because when you do the line test, it's twice.
Very good. If you do the line test, it hits twice. But it is part of the curriculum of college algebra, so we will discuss it. One thing about the circle is how to interpret the circle. If your equation is given, like so, we call this the center radius form, because you can grab the center of the circle and the radius just from this form right here. So let's see if we can try to interpret how to find the radius of this form. Notice my radius is 1, and my equation equals 1. If I were to change the radius to 2, my equation equals 4. If I change the radius to 3, 9. 4, 16. Can you sort of see the pattern?
Yes.
If my radius is 5, what would it be equal to?
25.
Very good, 25. So this equals the radius, what?
Square.
R squared. Very good.
Yeah.
Meaning, if I give you that my equation equals 100, then what is the radius? 10. So you're taking the square root of that. So yes, 100, my radius is 10. So it equals your radius squared. Now, not only can we increase the radius, given the equation, but we can also move it around. So remember our transformations. If I have a value inside with my x, it moves left to right. Same thing with the circle. I'm moving along this, my x-axis. Note that as I'm subtracting a number, it moves where? To the right. So my center is at 9, 0, but the equation is negative 9. If I move it to the left, I have h, my center at negative 10, 0, negative 10, 0, and what is my equation? Plus 10. So it kind of flips the sign, right? You can grab the x coordinate of the center by flipping the sign. Now what about the y? Well, same thing. If it's inside of a number, we're talking about the difference. So it kind of does the opposite of what you expect. So as I go up, notice I have a negative 3 in this case. And if I go down, I have a positive 4. So as I move my circle around, I have my center at 9, negative 4. Flip the values. Negative 9, positive 4. So if I make this x equals, let's see if I can do this, cover it up. What is my center of the circle?
Negative 5.
Very good. Negative 5, 2. You're just flipping these signs. So in center radius form, flip the signs. This will be your x coordinate of the center. This will be your y coordinate of the center. And then take the square root. That'll give you the radius. So I move over across here. So if I have something like a center of 10, negative 9, that I know is x minus 10, I'm flipping this sign, squared, plus y plus 8, flipping this sign, squared. So here, there's a link to this if you want to play with it in today's folder. What's that? No. Yes, today's will be for good. So as I see here, as I note, the center, the h coordinate, or the x value, is just the sign flipped. Likewise with the y, and the radius is the radius squared. So here's your, what we call center radius form. Just like if you can remember with quadratics, we had something called the vertex form, right? You can grab the vertex straight from that form.
Nice.
So let's see an example. If you can't read this, its center is at 4, 3. What is my radius? 5. R equals 5. So my goal here is to write an equation in center radius form given this information. So I have some x value squared plus some y value squared equals some r value squared. First off, what would I put here?
25.
R squared is 25. What would I put for my x?
Minus 4.
Flip the sign, so instead of plus 4, I have a minus 4. And what would I put for my y?
Minus 3.
Minus 3. Easy peasy, right? There's my equation.
Nice.
So one part of dealing with circles in college algebra is interpreting the center radius form, being able to write it, and then being able to give information from it. Another part is to write that form in general form. Don't ask me why, it's just part of it. So looking at this equation, x minus 9 squared plus y minus 6 squared equals 100. First off, what's my center? 96, right? 96. Again, taking the values and flipping the sign. What is my radius? 10. Since this is r squared, to find the radius, go backwards, I square root. That gives me 10. Now to put this in general form, basically what you want to do is set this equal to 0, and then simplify this, explain this out. So I want to write x minus 9 twice, add that to my y minus 6 twice. I want to distribute, and then combine like terms. So yeah, x times x is x squared, x times negative 9 is negative 9x, negative 9 times x is negative 9x, and negative 9 times negative 9 is a plus 81. Now with my y's, y times y is y squared, y times negative 6 is negative 6y, negative 6 times y is negative 6y, negative 6 times negative 6 is plus 36, and that equals 100. Again, we want to basically blow this problem up, distribute, and then now my step is to combine my like terms. So I have an x squared, adding my x's, 9x minus 9x is a negative 18x. I'm going to hold off on my constant 81. I'm going to put my y squared next, so plus y squared, and then add my y's. Negative 6y plus a negative 6y is a negative 12y. And I have a 36. And let me just add my constants at the end. So 81 plus 36 equals 100. We're almost done putting this in general form. Like I said, it needs to be in terms of 0 or solve for 0 or equal to 0. So let me subtract 100 on both sides. Now I get y squared minus 18x, or sorry, x squared minus 18x plus y squared minus 12y. And what is 81 plus 36 minus 100? Very good, thank you. That is going to equal to plus 17 equals 0. There is my general form of a circle. Again, I apologize. I don't see really the point of having the circle in general form. It's a lot more helpful to go backwards, but we are not going to go backwards today. To go backwards, what you would do is just look at the x and complete the square. Look at the y, complete the square, and then move your constants to the other side. So yeah, I'm still trying to think, why would you use general form? Well, I mean, you know the equation is equal to 0. That might help you somehow, but you got 2 variables, so it will create kind of a mess. But there's general form. So for this problem, while I take attendance, go ahead and find my radius, my center, and put this in general form. Not 3, 1, because it's kind of threw a curveball at you.
Oh, 1, 3.
Ah, yes, it is 1, 3. Please note that this is associated with my x value, and my y value. It's kind of flipped. And what is my radius? 3. Very good. Square root of 9 is 3. Now let's see if we correctly put this in general form. So let me write my, expand my x and y out. And we got some distributing to do. X squared, negative x plus 1, y squared, negative 3y, plus 9 equals 9. Hey, that kind of works out because I'm setting this equal to 0. So I can go ahead and subtract down here. That'll cancel with that. And let's simplify. So x squared, x squared minus 2x. I'll go ahead and write my y's plus y squared minus 6y plus 1 equals 0. Is this what you got for the general form? Hopefully I didn't make any errors. I don't see it. Looks good to me. So there's the general form of this equation.